Ratio and root test. Video 2. In video 1, we proved the ratio test. Video 2, we'll do some examples. Here's the first one. We're looking at linear n in the top placed over factorial. Which of these two is stronger, the top or the bottom? To apply the ratio test, what is it a ratio of? The next term over the current term. If this is the current term, write down the next term. Wherever you see n, swap it out with n plus 1. Wherever you see n, swap it out with n plus 1. 1 plus 1 is 2. Next, form up the ratio. The ratio in the absolute value. Now, taking one term dividing by another, when the terms are rational expressions, it's convenient to write down the top term and instead of dividing, multiply by the reciprocal of the other term. So, in writing down the top term, n plus 1 is good to go. The factorial, however, in order to produce a cancellation, write n plus 2 quantity factorial as n plus 2 times n plus 1 quantity factorial. Multiply that an plus 1 by the reciprocal of the current term. Denominator n plus 1 factorial appears in the top. Original numerator becomes a denominator. With a cancellation, we can see that we're going to come up with n plus 1 over n plus 2, and then alone 1 over n by itself. That'll limit to 1 times 0, and 1 times 0 is 0 as n is taken to infinity. Very good. What does this give us? Gives us that rho is 0. When rho is 0, that's the absolute convergence case. Yay! What is absolutely converging? The series determined by this sequence. How is it converging? It's converging absolutely. And what test are we applying? We're applying the ratio test. Fantastic. Let's do another. Here's the next one. The first one was showing that factorial is strong. Let's consider how strong factorial is versus exponential. Draw some pictures. Constant function, no change. Linear function, you've got growth. Parabola, you've got even bigger growth. Exponential, and exponential is super strong. So, Mr. Super Strong Exponential, how are you going to measure up to factorials? Let's find out. Okay. We know we want to look at the current term, look at its pattern to form up the next term. With these two terms, let's look at their ratio. How do we want to form the ratio? The next term over the current term. Writing down the current term, let's set things up so that we'll produce nice cancellations. E, having n plus 1 copies, let's divvy out n copies here and save 1 copy here. Same notion on n plus 1 factorial. Let's save n plus 1 and then apply the factorial just to the n. Here was the original term. Write down its reciprocal. Produce cancellations. After the cancellations, this constant over something getting really large will go to 0 as n goes to 0. Like the previous example, we're coming up with rho equaling 0. the series is absolutely convergent, we've used the ratio test. Back to the commentary, that large exponential stands no chance when placed up against a factorial. Go factorials. Let's do one more example. Aha. Now let's test factorials versus, well, in the previous example, it was a fixed base e. Here we're letting the base grow as the exponent grows. Quickly, you should see that there are n factors in the numerator, there are n factors in the denominator, but the factors in the numerator are larger or equal than the ones in the bottom. All right, so that factorial, which we thought was hot stuff, we should find is not going to compare to n raised to the n. Let's verify. Okay, so first, write down the next term. Wherever n is, replace it out with n plus 1. In setting up the ratio, do some clever algebra to clean things up a bit. Pull off one of the bases and times the base raised to n copies. Same story on the factorial. Here was the original term. Write down its reciprocal. That leads to nice cancellations. Now, sorry, I was looking for the other cancellation. There we go. Now, what are we left with? This. Put that all as one term raised to the n. Denominator is a single term. Push it underneath each term in the top. Produce this binomial. And then you need to recall an identity that this may be taken in the limit as e, as a definition of e. You can verify this yourself. That's a nice challenge. But it's good to know as a fact that this limits to e. How about that number e? Is e bigger than 1? Yes, it is. What's the meaning there? Well, remember, this row is like a ratio, meaning the common ratio, the geometric. Bigger than 1 means that your series will diverge. So as we were noting, n copies of n in the top are going to outstrip n times n minus 1 times n minus 2, getting smaller in the bottom. Very nice. That was 3 examples of the ratio test. Excellent.